Hi friends, in this method we are going to discuss about the indirect method for the generation of the frequency modulated signal. In the last lecture we discussed about the direct method for the generation of the frequency modulated signal. But there was a problem of the poor stability. To overcome that problem, we moved to indirect method. In the indirect method, this problem can be removed by using the crystal oscillator. Crystal oscillator provide the stable frequency up to 1 MHz. If we provide message signal as an input to the phase modulator, then the resultant phase modulated wave is given by AC cos 2 pi FCT plus kpmt. Let assume this equation as a. As we discussed earlier, in the phase modulated signal, the phase of the carrier signal is varies according to the message signal variation. And if we give message signal input as the to the frequency modulator, then the resultant wave is given by AC cos omega ct plus kf integration of mt. Let assume this equation as a b. As we see equation A and B, the basic difference between these two, as in equation B, integration of mt is as a phase term. So if we provide the integrator before the phase modulator, then the resultant signal of frequency modulated wave and the phase modulated wave is similar. So in the third diagram, we provide an integrator before the phase modulator. Then SFM is equal to the SPM wave. Now the question arises why we are discussing about this, because the diagram in the pink block is basically a phase modulator. So question arises why we are discussing about the phase modulator, because in this video we are generating the frequency modulated signal. Answer is this: with the help of the phase modulator we are generating the frequency modulator. So after the message signal we provide a audio equalizer, that is basically a integrator or active low pass filter, because active low pass filter is work as a integrator. So after this pink diagram, the generated signal is not as a phase modulated signal, it is a frequency modulated signal, and it is a narrowband frequency modulator, because the crystal oscillator provide a frequency range up to 1 MHz. So because of this frequency range, resultant signal is narrowband frequency modulated signal. Crystal oscillator provides a stable frequency cosine signal. Let assume this as a AC cos omega ct. Then this signal goes to A, that is buffer. So assume output of the buffer is AC cos omega ct. As we know that the cosine signal provides a impulse at Fc. So assume a impulse at Fc. Then this signal goes to a 90-degree phase shifter. So after providing a 90-degree phase shifter, output of the B is as AC sin omega ct. Then suppose audio equalizer is not present, we are discussing only about the message signal. So message signal and the AC sin omega ct goes as an input to the balance modulator. As we discussed earlier, balance modulator is simply as a modulator, that is as a simply multiplier. So it's simply multiply AC omega ct with the mt. In the double sideband suppressed carrier, we discuss about the ring modulator, that is balance modulator. So simply it multiply the signal. As we know, then that multiplication of two cosine signal, because default message signal is also a cosine signal. So 2 sin A sin B gives a cos A minus B minus cos A plus B. So we have a 2 cosine signal. So in this way we have a 2 signal. First frequency is as omega c minus omega m, and second frequency is as omega c plus omega m. So we have a upper sideband and lower sideband. Suppose we draw the vector combination of upper sideband and lower sideband. then the resultant vector is given by A. Then the output of the balance modulator, that is C, and the buffer AC cos omega ct goes to the combining network. Combining network add these two vector and the resultant is given by the hypotenuse of this triangle. So this form a angle phi. Let assume that the message signal amplitude change. So the vector A change into the vector B. So the resultant phi changes. So in this way we are controlling the phase of our signal with the help of the message signal. So in this way the working of the phase modulator works. So in this discussion we discuss when we are not providing the integrator to the circuit. If we provide the integrator to the circuit, then the resultant signal that generate is not the phase modulated signal, it is the frequency modulated signal. And because of the range of the crystal oscillator up to 1 megahertz, this is the generated signal is the narrowband frequency modulated signal. Then our basic block diagram change into the bottom diagram, in which narrowband frequency modulated generated signal is passed through the frequency multiplier, that is passed to the mixer. Then we got our resultant frequency modulated signal. If we discuss about the frequency multiplier is a square law device followed by a band pass filter. As we discussed earlier about the square law device, the output of the square law device is summation of the input term with the increasing power. Let assume square law device operation as a square. So if we provide input VIT, then we know that the input is basically a cosine signal. Then cos square theta is as 1 plus cos 2 theta by 2. So cos square 2 pi f naught t as 1 plus cos 2 into 2 pi f naught t by 2. And we know that this resultant signal is passed through the band pass filter, and we know band pass filter cancel out the DC term, which is half. So the resultant is cos 2 pi f naught t. Let assume that the operation of the square law device is as to provide the n power term. So if cos theta is as a input, then the frequency multiplier output is as a cos n theta. So we know that the input to the frequency multiplier is narrowband frequency modulated signal, that is AC cos 2 pi fct plus beta sin 2 pi fmt. Because this is narrowband frequency modulated signal, so beta is less than and equal to 1. So the output of the frequency modulated signal is wideband frequency modulated signal, because this term is multiplied by n. So output is AC cos 2 pi n fct plus n beta sin 2 pi fmt, where n beta is greater than and equal to 1, because range of the frequency is expanding because it is multiplied by the n. So the narrowband frequency modulated signal is changed into the wideband frequency modulated signal. Now the question arises, if we get wideband frequency modulated signal as the output, then what is the need of the mixer and to provide that local oscillator as second input? Because this is not as our desired output. Suppose we want to obtain 94.3 FM frequency as the output, and the output of the wideband frequency modulated is as 100 megahertz, or we can assume as a 95 megahertz. So this is not as our desired frequency. So we provide a local oscillator as an input to the mixer, and second signal as a wideband frequency modulated signal. Mixer basically two input, so it simply add the frequency and subtract the frequency. So 95, let assume that the crystal oscillator frequency is as 0.6. So if we subtract 95 from the minus 0.6, then resultant will be 94.3 FM or as a 95.6 FM. So in this way we obtained our desired frequency, and that is the role of the mixer. So in this way we obtained our desired overall frequency modulated signal.